This video summarizes a simple unified framework for detecting out-of-distribution samples and adversarial attacks. Deep neural networks can be generalized well when a test sample is from a similar data distribution. However, there are many kinds of unknown samples that classifier can't give a right answer. So, given a pre-trained deep classifier, detecting abnormal samples like out-of-distribution samples and adversarial samples is a really important problem in machine learning. To solve this problem, one can consider threshold-based detector, which measures some confidence score from deep neural classifier. Here is a main challenge: how to define a confidence score to detect abnormal sample very effectively. In this paper, we propose Mahalanobis distance-based confidence score on hidden feature space of deep neural classifier. Idea is very simple. Using training data, we first compute the empirical class mean and covariance metrics as shown in this equation. Then we can measure the distance between a test sample and average static of training sample. Because abnormal samples like out-of-distribution data and adversarial sample can be more far away from average static of training sample, we define this metric as a new confidence score. To further improve the performance, we consider adding small perturbation to the input data and ensemble of confidence score by extracting the hidden features from multiple layers of deep neural networks. We show that such a new confidence score is very useful for detecting out-of-distribution samples. As shown in this table, our method outperforms all prior methods. Also, for the problem of detecting adversarial sample, our method outperforms all prior methods as shown in this table. Finally, we apply new confidence score to class-incremental learning. Instead of training networks using the sample from new class, we design simple classifier which handle a new class by computing and updating a class mean and covariance metrics. As shown in these figures, the proposed classifier outperforms all baseline methods, including softmax classifier, by a large margin. In summary, we propose new confidence score based on Mahalanobis distance and shows that it is very useful for many machine learning applications. For more information, please come to our poster session. Thanks.